All right, let's talk about artificial intelligence. We're going to pull back the curtain and really demystify it. We'll break down how it thinks, how it learns, and, how it's already a huge part of our world using some simple, easy to understand building blocks. Let's just dive right in. So, when you hear the term AI, what's the first thing that pops into your head? For a lot of people, it's probably sentient robots or maybe some supercomputer from a sci-fi movie, right? That's the common picture. But the reality? It's much, much closer to home. Look, the thing is, AI isn't some far-off futuristic concept. It's already woven right into the fabric of your daily life. I mean, every single time your phone corrects a typo for you, that's AI. When your streaming service somehow knows exactly what movie you're in the mood for next, yep, that's AI too. It's the little co-pilot in your traffic app. It's the super sharp assistant helping doctors analyze medical scans. And it's the security guard that catches credit card fraud way before you even notice. It is literally everywhere. Okay, so how does it all actually work? Let's start with the very first, most fundamental building block. At its core, one of the earliest forms of AI is just a brilliant puzzle solver. Think of it as a system that's designed to find a solution when you know all the rules of the game up front. Here's the best way to think about it. Imagine you're placed at the entrance of a giant maze, but you don't have a map. Your goal is to find the exit. You know the rules. You can go forward, you can turn left, you can turn right, but you can't see the whole thing at once. The AI's job is to figure out a system to explore that maze and find a path to the end. Now, there are two basic strategies for tackling that maze. The first one is called depth-first search. Imagine you're exploring a cave system and you decide to follow one single tunnel all the way to the very end. If it's a dead end, you just backtrack and try the next tunnel. Simple. The second strategy is breadth-first search. This one is more like dropping a stone into a pond. The search spreads out from the start in perfect, ever-widening circles, exploring all nearby options first. So, two very different ways to get to the same goal. But what if we could give our maze explorer a hint? A little cheat code. That's exactly where a heuristic comes in. It's basically just an educated guess, a rule of thumb that helps the AI estimate how close it's getting to the goal. It's like giving it a compass that always points kinda sorta in the direction of the exit. It doesn't show the exact path, but it sure stops the AI from wandering off in completely the wrong direction. And this idea of using hints leads us to the gold standard of this approach. It's an algorithm called A-star. Think of A-star search like a really wise traveler on a long road trip. It doesn't just look at how far it is to the destination, that's the heuristic part. It also keeps track of the distance it has already traveled. By balancing both the cost you've already paid and the estimated cost to go, it finds the most efficient route possible. This is pretty much the logic that powers your GPS when it finds the fastest way to get you home. Okay, so solving puzzles when you know the rules is powerful stuff, no doubt. But what happens when the rules are just way too complex to write down by hand? What if there are like a million different variables? This brings us to our second huge building block, AI that actually learns from examples. And this right here is the absolute game changer. This is the core idea behind what we now call machine learning. Instead of a human programmer sitting down and painstakingly writing thousands and thousands of if-then rules, we completely flip the script. We just show the computer a massive number of examples and let it figure out the patterns and the rules all by itself. The most common way we do this is something called supervised learning. And honestly, it's just like teaching a child with flashcards. You show the AI a million pictures, and each one has a label. This is a cat. This is a dog. This is another cat. After it sees enough of these labeled examples, the AI starts to pick up on the underlying patterns, the features, that make a cat, and a dog, a dog. The supervision part is just us providing those correct labels. So how does it actually learn from all of those pictures? A really great way to picture it is to think of the AI model as this massive machine with thousands, maybe millions, of tiny little knobs and dials. Training is just the process of automatically tweaking and adjusting those knobs over and over again until the machine's output consistently matches the right answers. The goal is to get its mistakes, what the experts call loss, as close to zero as possible. Now, building one of these models might sound super intimidating, right? But in reality, the people who do this for a living follow a very practical step-by-step approach. First, you have to clearly define the problem you're trying to solve. Then you get all your data ready, and trust me, cleaning the data is a huge part of the job. After that, you always start by training a really simple model just to see if you're on the right track. And finally, you evaluate how well it did, and then you go back and refine it. It's this constant cycle of building, testing, and improving.
And at the heart of so many of today's most powerful learning systems, you'll find something called neural networks. And yeah, they're directly inspired by the structure of our own brains. They're made up of lots of simple, interconnected units, kind of like neurons, that all work together. A single one of these units can't do very much on its own, but when you connect millions of them together in layers, the network can learn to do incredibly complex things, like understanding language or recognizing faces in a crowd.
But how in the world do all those millions of knobs and dials get adjusted in just the right way? Well, this is where the real magic happens. It's a process called backpropagation, and here's an amazing analogy for it. Imagine a giant company makes a really bad decision. Backpropagation is like a full-blown audit that traces the responsibility for that mistake all the way backward, through the entire chain of command. It tells each manager exactly how they messed up and what they need to change. That, in a nutshell, is how a deep network learns from its own mistakes. So, AI can solve incredibly complex problems, and it can learn from massive amounts of data. This gives it an unbelievable amount of power. And that leads us to our final and, frankly, our most important layer, building it responsibly. This is the question. It's the one that every AI developer, and really all of society, has to wrestle with. Just because we can build something that's unbelievably powerful, does that automatically mean we should? And if we do decide to build it, what are our responsibilities? When we talk about AI ethics, what we're really talking about is aligning these powerful systems with our human values. And that really boils down to 5 core questions. First, fairness. Does the model treat every group equitably? Transparency. Can we actually explain how it's making its decisions? Privacy. Is people's data being protected? Accountability. When it messes up, who is responsible? And finally, safety. Is the system built to be robust against people trying to misuse it? These are not optional add-ons. They have to be baked in from the very beginning. You know, it helps to think of AI as just a tool, a very, very powerful one. Take a chainsaw, for example. It can do amazing work and be incredibly efficient, but you would never, ever use one without proper training, safety guards, and a clear set of rules. The exact same principle applies to AI. Powerful technology demands responsible handling. Period. Okay, we've covered a ton of ground here, from solving mazes to machine learning to ethics. So, what's the big picture? What are the key ideas you should really hold on to after all this? It really all boils down to 3 core concepts. First, you've got search. That's all about following rules to find solutions. Think of your GPS finding the best route. Second, there's learning. That's finding patterns in data. Think about your streaming service recommending your next favorite show. And third, and most importantly, ethics. That's about aligning AI with human values. Think of it as the safety manual for that powerful tool. Search, learning, and ethics. Those are the real building blocks. So the next time you hear about AI, don't think of it as some kind of impenetrable black box magic. It's not. Think of it as a map that's created from logic and data. It's a tool for helping us navigate incredible complexity. And now that you have a sense of how to read that map, the only question left is, where are you going to explore next?